Hello everyone, hello everybody. So in this videos we will speak about loads, but before load I had to put bracing in my structure. So as we know, bracing, the work of bracing is to transfer the horizontal effort to the foundation. For this reason, all the foundation is beamed. So the rotation in the foundation is not blocked, and especially when the structure receive the horizontal forces from wind. And as we can see, the frame, the beam in the frame support two kind of effort horizontal and effort normal. So I will consider there is a concrete block wall in the facade of the building here, and in the middle height of the side of the building, and here too. In these cases I will not consider here there is a wind forces. So in these cases I will not put end wall column here and here. So bracing, so we need to add elements in the structure. Normally bracing is about cornea. I will choose for this structure, I will choose, for example, 64. And I can add it. It's not really here if I have wall concrete, but they can do it. It's not a problem. So I can 1 2 3, then 1 2 3, 1 2 3. Now I can copy it, so I can select from here the section, this section, so not bad. So I added the bracing. Then we talk about load. To apply load to our structure, we need to design panel. So to apply the loads, I have to add cladding to my structure. So I will select it and isolate. So I will isolate the burden, I don't know, and the bracing, that is not a problem. So this is my structure, and then cladding. Yes, so I will determine the cladding. I have to pay attention the point where I apply my cladding. The same way here. So as I said, there is a concrete wall here, concrete block wall. So the forces apply in the middle. So the same way here. So here we have four surfacic loads. This surfacic load will transfer in direction X or Y. So I can determine it. It depends to the space between Berlin, and in the concrete depends the type of reinforcement, steel reinforcement in the concrete, the direction of the reinforcement. So as here in steel structure we have Berlin, so the surfacic loads will transfer to the Berlin. So we have one direction loads, and this load will transfer a punctual forces to the frame. So here here I want to put cladding, because I said there is concrete walls the same way in the end of the building. So the second step is to define in which axis the load will transfer. So I can select the cladding, isolate it, and then so this cladding is via axis X, this Y, this X, and this Y, this Y, and this Y. So this if I have if I put small beam between column, I can change the orientation of the forces, but here I suppose the forces will transfer directly to the column. But if there are small beam, we have to design it. Normally there are, but I don't put it. So I try to do light model, not a lot of column and beam. Normally there are beam here between column, but I don't put it. And if there isn't a concrete wall, so there are here column, so end wall column here, and there are small beam to transfer forces to the column and then to the foundation. So now we define panel. Now for load, so I will define the type of load what I have. So I have dead load. Okay, I can enter here. So it depends what the purpose of this structure. Normally I don't have live load. I can because if I have live load, it's a big value of live load. So the structure will support a lot of loads, a lot of efforts. I can put materials in my roof. I can put, for example, solar panels. I can put equipment, clima equipment, for example. It's dead load, but the difference is not non-structural. So in this way, I have wind, I have snow. Okay, not a problem. Wind, I cannot put wind, because wind we will calculate automatically by remote structure, so it is useless to add it. So like that we are okay. Now we can run the calculation for determine the dead load of the structure. The self weight, my model is ready. Here I can apply forces, so I defined it before. So dead loads, no, it's okay. So I can put, for example, I can put from here dead load 2 surface here on decanewton. So I can put it, for example, 10 decanewton, and I will apply it here with control here, and then apply. As we can see, the load in the other direction. So because I don't add mine to change it, so load here. So as we can see here, I can add minus, and we are okay. So we have self weight, we have here uniform surfacing, and we have all the element. It is not projected, this is just for the snow. So it's all for this video. In the next video we will talk about wind forces and how to calculate it automatically and manually by Aerocode. See you in the next video. Don't forget to put like.